Hello everyone, my name is Jacob Tifo. I am a 6-year member in the Electric Project and a member of the Friends Forever 4-H Club. I'd like to share something that I've been working on through my model rocket association called alphaomegarocketry. And it is our first generation flight computer. But before I get into the specifics of that, I would like to thank all of the people that made the 2020 4-H Fair go on. With COVID-19 and everything going on, I know for some people they were on the fence about it, but nevertheless, I want to thank our distinguished judges, our club leaders, our project leaders, our junior leaders, and actual 4-H members, people at the office, people on the maintenance staff. I just want to thank you all. The project that I would like to show you is my ZETA Generation 1 computer, or ZG1. This is a data collector for a model rocket. So this is how we can get acceleration data, gyroscope data, and altitude data on a rocket's flight. To break down all of these wonderful components, I have this handy-dandy little picture, and we're just going to kind of work our way through it. The first one, and probably the most important, is the Teensy 4.0. This is our Mark controller, or our microcontroller. It is the strongest microcontroller on the market right now. It can clock 600 megahertz just sitting on the table, or if you overclock it, it can get upwards of 800, 900 megahertz. And if you were to put cooling on it, you could get 1 to 1.2 gigahertz of processing power. It is a wonderful microcontroller. Our next batch of things I'll go through is the sensors. The MPU 6050 is our gyroscope and accelerometer. This is able to tell our accelerations. So, for example, gravity's acceleration is pushing down on us at a constant of 9.8 meters per second squared. And it can calculate that. It can also calculate the different angles that we are at. So, angles in this way, that way, and let's see, in this way. And by doing that, we can then depict where we are in three-dimensional space, X, Y, and Z. We also have a BME 280. This is a barometric pressure sensor. This way, we can take the barometric pressure of the atmosphere around us and turn it into altitude based off of a constant sea level pressure, which is approximately 1013.25. That is the constant, and you can get a pretty accurate altitude estimate. In order to be able to record this data, we need two things. One, we need a memory chip, and two, we need a micro SD card. That way we can actually read the data on a computer or another device. Now, when I first started, I looked at going directly to the SD card, and there were a few issues with this. The first issue being when you write to the SD card in a launch or in a high volatility atmosphere, the data does not like to flow between the electromechanical connection of the SD card and the SD card socket. So I had to find a better way, and one of those ways I found was through a memory chip or and we use a FRAM chip. FRAM stands for Ferroelectric Random Accessible Memory. RAM is no stranger to many people. It is in your phones, it is in computers, it's in about any electronic processing unit. But what makes this specific memory chip special is that it is ferroelectric. For anyone who has taken physics, you might have learned about ferroelectric and the properties of it and how how efficient it is. So that is what we use. The other things we have on here is we have our terminal block. This is connected to our 9-volt battery and 9-volt battery clip. That's what we use to launch to record the data of the rocket, and it went very well. It sustained multiple flights, and we were very happy with it. Other things we have on here is the RGB LED. This is the red, green, and blue, so it can be technically any color with using those combinations. And we have 220 ohm resistors to help step down the power so it's acceptable to the light. The LED can be used to tell us errors or saying a certain thing is happening. So like, let's say writing to the memory chip is taking place, or writing to the SD card is taking place, or we have an error and nothing is happening, or we're on standby and it could be blinking. Another crucial part of the entire design was these 5-volt regulators. The FRAM memory chip and the Teensy 4.0 did not have level steppers on them. It could not step the power down from whatever it was, for example 9 volts, down to 5 volts, in order for it to be acceptable to the component. So we had to add these externally, and then we just ran jumper wires to the VCC or VIN outputs on each. Another great thing that we did was here. This is a just diode N something. I'm sorry, I do not have that with us right now. It's just a regular diode, and we connected to the USB and the VIN in order to be able to run it on the desk off of USB power and in flight with a 9-volt battery. That is there because of the properties of a diode only going one way, so we didn't have any power surge back into the microcontroller. A few things about the board as a whole. We used proto board. It did not have any general direction. It just it had perforated holes and conductive metal for better connection. We also used resin solder. Resin solder helped us to be able to keep everything nice and clean, especially since, I mean, you're bound to have a few mistakes in your soldering, so we could clean those up and we could retry them. And then our jumper wire was 22 gauge wire. I'm not sure if I already said that, but that just kind of kept everything, it wasn't as bulky, and we could kind of, we also used, I should also say, we used soldered, solid wire, so we could actually bend it and make it pretty straight. Sadly, I don't have a picture of the underside of the board because it's stuck in a tree. But that is a data logger for you, and we were able to get 2, and I'm almost positive 3 successful tests, even though one was not recoverable. And to prove the memory chip actually worked, the rocket crashed and the SD card popped out. And thankfully, it recorded data still, so those were somewhat successful. As I kind of put this later, I would have it physically, but it's in a tree. But I want to thank you for tuning in. If you'd like to learn more about just some of my electronic projects and things like that, you can check out my YouTube videos at alphaomegarocketry. You can also check out my website, alphaomegarocketry.space, for other cool projects, and also updates on our thrust vector control and our ZETA Generation 2 and ZETA Generation 3 flight computers. But I want to thank you all for tuning in. May we have a fun rest of the summer. May we be safe, and that go have fun and enjoy the fair. I want to thank you all. Bye.